everyone. This is the last assignment of our 8-week Pre-AMC summer practice program. Let's look at these problems. Question number 1. Here we have several angles. The largest one, PQR. PQR, this is 138 degree. Then we have SQR. This is 90 degree. All right. Then we can quickly get the angle PQS. This is just 138 minus 90, which is 48. So this is 48. Okay, we need to find is the angle that is in the middle, SQT, right? Since we have this one is also 90 degree, so this is also 90 degree. Then we have the question mark is angle equals 90 degree minus 48. That's 42, right? 42 degree. Okay. Problem number 2. So here we have two three-dimensional figure. The one on the left-hand side is a cube, and the one on the right-hand side is a cube, but some blocks are missing. We need to figure out how many cubes we need to, small cubes we need to put in order to form the large cube on the left-hand side. All right, so we just count one by one. So here we have, obviously we have one here, we need one here, and then we need one here, and we need one here. Also, we need one here and one here. But then we need to go up, we need two extra 2, right? So if you want to go up, you have one and one here, right? Okay, so if we put together in total equals 7. Right? So we need to put 7 small cubes on the right-hand side in order to complete the bigger cube. Okay. Problem number 3. This is a problem about a probability. So here we have this circular spinner. It's divided into 8 sessions with equal areas. So that means this arrow has equal chance to be on any of these 8 sessions. Okay, so what's the question? The question is, what's the probability that the arrow stops in a session contains a prime number that's odd? All right, so let's mark those prime numbers that are odd. So this is odd, right? So we have this 3, and then 5 is odd prime number, and 7 is odd prime number. All right, so that means among these 8 sections, 3 of them are what we want, right? It's the target domain. So we want the we are looking for the probability that the arrow could stop in one of the 3. So then clearly the probability we know is the total total scenarios. So total scenario. So that's the 8, right? So this is the number of total cases. And then we look at the number of good cases, right? So that's 3. So this is the number of good cases. Okay, so we get the probability is 3 over 8. All right. Problem number 4. This is again a problem, a puzzle about ages. So it says Hector's father's current age is 5 times his age, and 3 years ago his father's age is 8 times Hector's age. So what is the sum of digits of father's current age? All right, so we need to figure out father's current age. The quickest way to solve, or I could say the most efficient way to solve this kind of problem is to use algebra. So I'm going to introduce a variable which I call x. So I let x to be the age of Hector, the current age of Hector. All right, so let me put it here. So we have father and Hector. This is the current age. I put this to be x, and then we have the age 3 years ago. Age 3 years ago. Maybe I just put 3 years ago. All right. Okay, so if the current age of Hector is x, then because here says currently father's age is 5 times Hector's age. So this one will be 5x. Okay, Then 3 years ago, Hector's age obviously is x minus 3, right? And father's age is 5x minus 3. Now here, why I use x to denote Hector's age instead of father's age? That's because if we use x to denote father's age, then we have to deal with fractions. Because if x is father's age, then Hector's current age will be x divided by 5. We try to avoid fractions if possible, because it's not so convenient to compute things that involve fractions. All right. Okay, so now what we need to do is only set up equation, right? So our goal is to set up equation. We need to set up an equation. So how should we set up equation? So far, we haven't used one condition, so which is given in the problem. It says 3 years ago, the father's age is 8 times Hector's age. So it's right here. So 3 years ago, father's age is 8 times Hector's age. All right, so based on that, we get, this is Hector's age 3 years ago. This is father's age 3 years ago. Okay, so then we get, it's 5x minus 3 equals 8 times, right? So it's 8 times Hector's age, so that's x minus 3. All right, so let's solve this equation. Here we have x minus 3 equals 8 times x and 8 times 3. We have 8x minus 24. Then we move x to the right-hand side and numbers to the left-hand side, right? This tells us we get 3x equals 24 minus 3, that's 18. That's 21, sorry, this is 21. 21, then x is 7. All right, this tells us Hector's current age is 7. Great, we get this one is 7. So father's age is 3, is 5 times 7 is 35. If we add together, 3 plus 5, because here the problem asks for the current sum of digits of the father's current age. So we add sum of digits, 3 plus 5, that's 8. The answer is 8. Problem number 5. Here we have 3 positive integers a, b, c, d. All of them are greater than 3. Also, we know 1 over a minus 2 equals 1 over b plus 2 equals 1 over c plus 1 equals 1 over d minus 3. Now, based on this equality, we need to figure out the order of these 4 numbers. All right, you see, because all denominators are 1, then in order for those fractions to be the same, all numerators have to be the same. This says we must have a minus 2 equals b plus 2 equals c plus 1 equals d minus 3. Okay, for convenience, let's just focus on b plus 2. We have, let me rewrite this equality. So we have a minus 2 equals b plus 2. And this, of course, if you do algebra, move 2 to the right-hand side, we get a equals b plus 4, right? All right, so then we also have c plus 1 equals b plus 2 from here. Again, if you move 1 to the right-hand side, just you get it becomes minus 1. And then we have the c equals b plus 1, okay? Finally, we have a d minus 3. This is also the same as b plus 2. Again, we move 3 to the right-hand side, and this gives us d equals b plus 5. Okay, now, given this information, we have a b itself right here, right? So this is b. Okay, so then clearly, this one is the smallest. And the second smallest is c, that is b plus 1. Then we have is a, right? So a is d plus 4. This is the second largest. And the largest one is d, that's b plus 5. So if you write out, we should have is b is less than c, less than a, less than d. So this is the correct order among these 4 numbers. Then the answer is the last one, E. All right, problem number 6. Emily writes down the largest. So first of all, here we have the largest. It's 2-digit, it's prime number. And also each of the digits is a prime, okay? And then Krish writes down the smallest 2-digit prime. Similarly, each of the digit is a prime, all right? Okay, so then we do the difference between these two numbers and what is the answer. First, let's figure out what is Emily's number. And then we figure out what is Krish's number. All the 1-digit prime numbers, 1-digit prime numbers, 1-digit prime numbers. We have is 2, and then we have is 3, and 5, and 7. Okay, so now we want to make the largest 2-digit prime numbers using these 4 digits. Clearly, what we should have is 73. Now you may think, why is not 75? But because 75 is not a prime number, since it's divisible by 5 because the last digit is 5. Now Krish is the smallest. Smallest. What is the smallest? So this is the smallest, and this is the largest. Right? So in order to make the smallest, we do is 23. 23. So this is smallest. Now we take the difference. 73 minus 23, the answer is 50. Problem number 7. The problem says last night, 5/8 of the students in the dorm look at Facebook, 3/8 look at Twitter, and 1/4 look at both. The question is, what fraction of students look at neither? For this kind of problem, the most convenient way to solve is to use a Venn diagram. So Venn diagram is, we are going to draw 2 circles, and each circle represents one part of students. So here's one part is for Facebook, and the other one is for Twitter. Okay, so I'm going to use the Venn diagram. All right, so this represents, a rectangle represents the whole body of students. And then we have circle inside. This one means Facebook. Students look at Facebook. And then we have students look at Twitter. All right. Okay, so we know the fraction of students who look at Facebook is 5. This is 5/8. So this is 5/8. And then look at Twitter is 3/8. Now the overlap is both, right? Look at both. So this overlap is 1/4, right? It's 1/4. Okay, we need to figure out is the fraction of students who look at neither. So that's everything that's outside. All right, okay. So what are we going to do? So step 1, we need to figure out the collection of all students, which they either look at Facebook or they look at Twitter. So we need to figure out the fraction of students who look at Facebook or Twitter, or both, right? Or both. Okay, so if you follow this Venn diagram, it's clear. So this one equals 5/8 plus 3/8. And then we also need to minus 1/4. Now, why do we need to minus 1/4? Because 1/4 is the overlap. When we add these 2 parts together, 1/4 is counted twice. So that's why we need to minus it. It's the overlap. Okay, so from here, let's calculate this. This one equals 1 minus 1/4, right? So that's 3/4. All right, so this is the part of students who look at one of them. So this part is 1/4. All right, so then everything outside, we are looking for the outside, right? So the outside will be step 2. Neither is 1 minus, the total is 1, and then minus 4/3, so that's 1/4. 4, right? So the outside is 1 minus 3 or 1 3/4. So that's 1/4. That's everything outside.